Hello guys, my name is Balkrishna Srivastav and welcome to CodeWithBK. So in this video we solve question 11 in specimen paper of ISC 2023 computer science paper, theory paper, which is to insert node in front of a linked list. So before we begin, it is a humble request. If you like this video, please subscribe to my channel because your support is very important for me to grow on YouTube. So the question says that you have been given a class node which has int num node next, okay, and you have to insert a node in an already present linked list, the head, the first node which is given by start pointer, and you have to insert the integer n in a node in the front of the linked list. So you understand this is a class node. It has an integer value which is the data in this node and a link to the next node. This basically makes this, okay, a node in the linked list. You need this variable because you need to connect this node to another object of type node. That's why we have a variable of type node in this class node itself. So right now this is an integer. It can be a character, it can be a boolean, it can be a string, it can be a double, it can be any value. It can be a non-primitive data type as well, say maybe another class, okay? But they won't go into that much complication. They'll give you some primitive data type like int, char, double or float. Okay, you have to insert node in the front. Now what does that mean? So let's take a sample linked list. So suppose I have this linked list 10, 5, 8, 6, 2 and null. Okay, this is basically representing a linked list which has 5 nodes and has values within it, an integer, because we have an integer value. So data is int, okay, each of these nodes has an integer value and these represent the next, okay, the links, okay. This is the data which is num, okay, in this case 10, 5, 8, 6, 2. The next of the last node in a linked list will always be null. This is a standard, this is the way we define a linked list. And the first node is pointed by a head pointer. The name of head is start ptr in this case. So I will use this, or I will use the word head. It means the first node in the linked list. And this head variable is very important because you always have a head in the linked list, and this is what defines a linked list. This is the starting point in the linked list. So whenever you have a linked list, it will always have a head. It might have a tail as well, okay? In certain cases, you might be given another variable of type node tail which will point to the last node. In this case, we are not. So they want to insert the node at the front, okay? So there are other two cases when you insert node at the last or you insert node in somewhere in the middle, okay? We'll cover those cases in separate videos. Right now we need to insert node at the head. So what do they want is, suppose they want to insert a value n, okay? I'm not taking a value inside, I'm just saying n. So I have to create a new node. N is the data, okay? So next should point to the current head, which is start pointer, and I'll leave this, okay? And then the start pointer, instead of pointing to this, so I'll cross this, I'll say it should be pointing to this new node, okay? So step A is create new node, okay? Step B, okay, is link. This is step B, link new node to head. So head is the next of this new node, okay? Step C is set start pointer to new node, okay? These are the 3 steps we code in order to add a node to the front of the linked list, okay? So when this happens, this link is lost, okay? This is pointing to this node which is the first in the list. The next of this is now the previous head which was 10 and then the remaining list, okay? So now the list which was 10, 5, 8, 6, 2 and null becomes n 10, 5, 8, 6, 2 null and start pointer is pointing to this new node. Ideally, the return type from this method should be a node type because you should be returning the updated head. So in the end, you should be doing like return start ptr, okay? So that the function that calls this method and passes this start pointer should get the start pointer back again, and that value in that start pointer which was called should be updated, and the return type should be ideally this, okay? But in ISC papers, I've always seen they always keep the return type to void, so we never return anything, okay? Remember this, we only insert and we update the head and we leave it as it is, okay, for our ISC paper. So we code exact these 3 steps. A is creating a new node. So A is create new node. So A is creating new node, and so how do we create a new node? We call the constructor, we use the new keyword, we say node, new node is equal to new node. And what constructor do we call? We call the default constructor that does not take any parameters, because this class node does not define any constructor in this question. Okay, so this gets a default constructor. Okay, and you can see num and next, they don't have any access modifiers. It means you can access them directly using the object name from outside the class. So if I want to set num to n and next to null, so I can say new node dot num. Okay, I can directly access the value num, okay, from this object, because it does not have any private access modifier. I can say this is set to n. Okay, I don't set next to null because I need to set next of this new node to this start pointer. So B is, okay, link set next of new node, okay, nn to start ptr. Okay, so you say new node dot next is start ptr. Okay, and finally the third step, set start pointer to this new node. So we have the updated head, set start ptr to new node. So start ptr now points to new node. Okay, so these 4 lines of code, these two, this and this, basically inserts a new node with a value integer n to the front of the linked list, and it updates the start pointer. You don't have to return the updated head, so we leave it as it is. We don't return any value. Okay, so they mentioned one more thing in this question, that start pointer is basically carrying a linked list, and it is an existing linked list. What they mean to say is this list is not empty, that is start pointer is not null. Okay, because if head, or if say basically the first pointer, okay, the first node is pointing to null, it means the list is null. Okay, so you can add a case where you can check if head is null, okay, in which case the list is empty, but you don't need to. Okay, I'll add the case, but you don't need to, because they say it's an existing linked list. So for a case, if the list is empty, you create a new node and you set the head to new node. Okay, because this new node is going to be the single node in the linked list, so head should be pointing to this. So start pointer should be pointing to this new node. If start ptr is null, it means the list is empty. We set start ptr to this new node. Okay, and we also set the next to null, because we are not setting the next to null here. So we say start ptr, or you can say new node dot next as well. They're both pointing to the same objects dot null. Okay, and then you do else, and then these two, the B and C, become the else part. Okay, so this was the solution to this question, and I'm going to code it in the system as well. But before we move on to that, it is a request, if you like this video, if you understood this, if this was helpful, please subscribe to my channel, because it is your subscription that is going to help me grow on YouTube. Okay, so let's move on to running this code on the system now. Okay, so this is the class node that we had. This is the insert node function that I have written. Okay, 3 points. Okay, and this is not returning any value, just as it was mentioned in the question. All right, and I have written another helper method to print the list. Okay, so I've created 5 nodes here. Okay, and I've linked them so that it becomes 10, 5, 8, 6, 2. So what I expect, okay, here is 10, 5, 8, 6, 2 and null. Okay, so let me run this. 10, 5, 8, 6, 2 and null. Okay, now I will insert a node using this function with this start pointer at the front. I'll say functions dot insert node. Okay, I will say start pointer, and I will say I want to insert 100. Okay, and then I print this again. But you will see this linked list output will remain unchanged. I will tell you why. Okay, why this is happening? Because as I told you, when you update the head, you have to return the updated head, so that the head in the calling function, which is this, should be updated as well, which is not happening. So inserting a new node at the front is happening. Okay, because if let me just take this and print it here. Okay, oh, I just need to call print list. Okay, because they are in the same class. Okay, and I'll remove this. So what is happening now? This initial list is printed, which is 10, 5, 8, 6, 2 null. Okay, you will get this output, and then we are calling insert node. So insert node is basically inserting a node at the front, which is 100, and then printing the updated list. Okay, so we'll get 100, 10, 5, 8, 6 to null. We'll get this new list. Okay, we get this. Okay, but if I print this back again, okay, the third output is going to be the original list without 100, which is this, because head is not being updated. So to update the head, we change the return type to node. Okay, and in your ICSC papers they mention the return type as void only. So if they mention return type as node, only then you return the start pointer. Okay, otherwise you leave it as it is. So when I return start pointer, I will update the start pointer when I insert node. Okay, and now when I print this list, okay, it will be updated. Okay, all right, because this print I commented out. Okay, the second print is printing the updated list. Okay, I will add one more value. Okay, say 11, and you will see 11 is also added to the front. Okay, so I hope this video was helpful. So please do like this video, subscribe to my channel, and please let me know in the comments if there was anything not clear to you in this video, if there is a question you want me to solve, or if there is a concept you want me to discuss. Thank you.